Good morning, students. Today we'll start our lecture 10 on crop water requirement and water use efficiency. What is water requirement of the crop? See, it's very important for us as an irrigation engineer or an agronomist to decide how much quantity of water is required for plant growth and development. For a luxurious growth of the plant, how much quantity of water is required, and such that it should not go waste or it should not be lesser that affects the crop yield. Under such circumstances, it is very important for us to determine the water requirement of a crop. Coming to here, crop water requirement is the water required by the plant for its survival, growth, development, and to produce the economic part. How much quantity of water is required for the plant to produce, and with respect to supplementing its survival, growth, and development, we call it as water requirement. The water requirement includes the losses. So when we talk about a plant water requirement, what is water required for the plant? It is required for its meeting its evapotranspiration demand, meeting its food requirement, meeting its metabolic needs. So that is what the water requirement. It includes the evapotranspiration or consumptive use, what we call. And during the application of irrigation water, quantity of water required for the special operations such as land preparation, transplanting, and leaching. So in turn, we can call it as water requirement is equal to consumptive use. CU is for consumptive use, and AL, that is application losses and water required for the special need, and WSP we call it as water required for the special purpose. So water requirement of a crop is equal to the water required to meet the consumptive use of water, water required to meet the special purpose need or application losses, and water required for the special purpose need. So it combined all this is the total water requirement of the crop. So generally we call it as water requirement is equal to irrigation requirement. So when I am talking about this water, how you are giving either irrigation requirement or effective rainfall through rainfall and soil water contribution. That is, water requirement is equal to IR, the irrigation requirement, effective rainfall, and the soil contribution creates the total water requirement of a crop. Water requirement is equal to total water requirement. Hence the idea of water requirement is very essential for the farm planning with respect to the total quantity of water needed and its efficient use of various cropping schemes of the farm. The combined loss of evaporation and transpiration from a crop field is termed as the evapotranspiration. See, this is very important term. What is evapotranspiration? When the loss of water which is taken from the plant, we call it as transpiration. When it is taken from the land surface, we call it as evaporation. The combined loss of both, we call it as evapotranspiration or consumptive use of the water. So when we have this formula, water requirement is equal to irrigation requirement, effective rainfall, soil contribution. From this formula, we can calculate how much I have to give through irrigation. So irrigation water is equal to water requirement minus the effective rainfall plus the soil contribution. This is given by nature. So this, when you are artificially applying the water, it is equal to water requirement minus effective rainfall plus soil contribution. So the irrigation requirement depend upon what factor? The first is irrigation depend upon the individual crop, it depend upon the area of the crop and losses in the farm water distribution, and all the quantities are usually expressed in terms of the hectare or centimeter per hectare. Coming to the potential evapotranspiration. Before going with the understanding of how this evapotranspiration is calculated, we need to understand potential evapotranspiration. It was given by Penman in the year 1948. What it says? How potential evaporation is calculated? The amount of water transpired in a unit time by a short grass crop of uniform height, completely covering the ground and never short of water. So you consider this is the land. This land grown with the complete grasses and the soil is good under field condition, no short of water. And evapotranspiration measurement under such condition we call it as potential evapotranspiration. And he further stated that potential evapotranspiration cannot exceed the tan evaporation. So this evaporation value and the potential evapotranspiration and the condition of the soil when covered with the grasses and completely covering the saturated condition or condition with a good moisture condition, and it should be always be lesser than that of a tan evaporometer value. So he further stated that potential evapotranspiration cannot be more than the fan evaporation. And how to estimate the potential evapotranspiration? We have certain device such as lysimeter, or we can use energy balance, aerodynamics approach, combination of energy balance and empirical formula. And irrigations can be scheduled conveniently based on the knowing potential evapotranspiration. So empirical formulas are there where we use instruments such as eddies covariance, lysimeter. So these can be used to calculate the potential evapotranspiration. So the amount of water has been evaporated gives the data that how much water has to be irrigated into your field based on the IW by CPE ratio. This is an standard USWB Class A open fan evaporometer, which is to be placed on a wooden platform where water level evaporated from this can be taken from a scale present in the steering well. Evapotranspiration can be measured either by lysimeter, a device where generally depicts the field condition, and you measure the water losses from a larger field, or you can use water balance approach, inflow and outflow of water, empirical methods, and we have the empirical methods. In empirical methods, we have blandly cradle method, radiation method, fan evaporation method, and modified Penman method. So we need not go for deep here. So in the blandly cradle method, it has a more error, 25% possible error in case of blandly cradle method. In the radiation method, which uses only radiation data, which have an error of 20%. So among these, the modified Penman method is best of all the methods in order to measure the evapotranspiration. This is the lysimeter. Yeah, we'll end today's class here. Next class, we'll deal with each method how we'll measure. Thank you for the hearing.